Just do a quick review. Let's just do a quick review about what we learned last class, which was how to actually graph sine and cosine. First thing is we saw that our x-axis will be theta, will represent the angle theta, and our y-axis can be sine or cosine, depends on our choosing. Your exit slip last class was to graph both of them on the same graph. Most of you guys did a really good job at that. So hopefully what I'm going to do right now won't be too scary. So in yesterday's exit slip, I asked you to graph sine and cosine on the same set of axes. The reason for that was for you to see that even though they look very much the same, some things have to be very clear in your head regarding the differences between sine and cosine. And the first big difference is that sine will always start at 0, 0. And it's going to go up, down, up. And cosine is always going to start at 1 or 0, 1. It's going to start 1 unit up. And it goes down like a bell. If we had the negative x-axis over here, you would see that cosine looks like a bell and sine looks like an S. Second thing you're going to notice is that I drew this sine graph. I labeled the x-axis in degrees. I did this just to make your life easier so that you remember that we're actually talking about 90, 180, 270, and 360 degrees. But on your test, you will only get graphs with the x-axis in radians, okay? So once again, it's important for you to not only memorize these values, but to remember what they represent in degrees. You should know that pi over 2 is 90 degrees and pi is 180 and so on. So what we're going to look at today is we're going to look at finding or identifying the critical points on a sine or cosine curve. And the critical points are either the points of maximum, the points of minimum, or the x-intercept. So if we take a look at our sine function up here, we're going to see that the first critical point on the sine function is an x-intercept. The first critical point on the cosine function, however, is a point of maximum. So that's important for you to know that for the cosine function, the first point on your graph is a point of maximum, which means that the next point you're going to graph can't go up, it has to go down, because you can't have anything higher than your point of maximum by definition, right? Going back to the sine graph, we have a point of maximum at 90 degrees, an x-intercept at 270, a minimum, or sorry, the x-intercept at 180, a minimum at 270 degrees, and another x-intercept at 360. Same thing over here. So we have, or a similar thing over here, we have an x-intercept at pi over 2 for cosine. For cosine, we have a minimum at pi, another x-intercept at 3 pi over 2, and a point of maximum again at 2 pi. What I need you to realize is that the distance between these points, between these critical points, is always the same. In the sine or in the cosine graph, the distance between each critical point is always the same. Something else that you're going to see is always necessarily between a point of maximum and a point of minimum, there is an x-intercept. And between a point of minimum and a point of maximum, there's always an x-intercept. So that's something important for you to keep in mind also. The last thing I want you to realize is the following. Last class, I showed you how the period of the sine function is equal to 2 pi, or in degrees, my period is equal to 360 degrees. So I want you to look at this graph over here and take a look at how many critical points we have in 360 degrees. So from 0 to 360 degrees, we have 4 intervals of critical points, right? The same thing happens with cosine. So the period of cosine is 2 pi. And we can see that from 0 all the way to 2 pi, there are 4 intervals between the critical points. And this is a very important piece of information because once we start changing the period, we're going to have to find the distance between the critical points. And for every sine and cosine function, you can find the distance between the critical points by getting the value of the period and dividing by 4. So let's suppose you're asked to graph a sine function where the period is equal to 4 pi. So if the period is equal to 4 pi, and you know that the interval between each critical point, you find it by getting the period and dividing by 4, you can get 4 pi divided by 4. This is going to be equal to pi. This means that this is the interval between the critical points. So let's find this interval first. First thing is, you know, it's a sine function, so the sine function always starts at 0, 0. Then you have your first critical point, but your first critical point is not going to be at pi over 2. Your first critical point is going to be at pi. So this is going to be, let's mark this over here. This is going to be my first critical point, which means that the next critical point is going to be another pi units away. So from here to here we have pi, another pi units away. We're at pi. Pi plus pi gives me 2 pi. So that's going to be my next critical point. Now I have to remember that for the sine function, we started at 0, 0, and the next critical point is a point of maximum. This means that I have to graph my point of maximum at pi, right? Because this is where my next critical point is going to be. After my point of maximum comes an x-intercept. So let's graph that x-intercept over here. And right now, if this is a piece of the graph that you have, you are done because you don't have any more of the graph to graph. So that's going to be the graph of a sine function where the period is equal to 4 pi.